So before starting the topic, it's always good to know how this topic was invented or what is the need of it, how it will help us in our real life. After knowing this topic, you will be able to solve an equation like this. Any number raised to any power, for example, that power is unknown to us, we can easily find that using logs and antilogs. At the end of this video, you will understand how to solve an equation like this. So, logs and antilogs are nothing but simple functions, simple special functions actually. So, if you have a number like x, which is a variable, f of x, like example, can double it. Now, logs are special functions. They do not have a specific formula associated with it like doubling, tripling or so on. They simply give a value of x which is different at different points, but their properties make them so useful in mathematics. It is written as log of x or antilog of x. Base 2 and value. Now this is just for telling you how to write logs and antilogs. So they are written as log base 2b of v equals a. That means here b is base 2, v is value and a is answer. These are the three numbers associated with logs. I have named these numbers by my side so that they might be understandable. Now base 2 remains the same mostly, but value changes. The most common used base 2 are e, which is the exponential function, which varies as e raised to power x, and the number 10 we know in maths. Antilogs also have base and value. Now what are logs and antilogs? Now antilog is something that takes the number to the power. Like antilog of 3 will take it to the power of base 2. Similarly, e raised to power 4. Now logs are something that tell us the power of the number. Like log of 10 base to 10 will be 1. Log of 10 raised to power 3 base to 10 will be 3. Similar for exponent also. Now properties of logs are what make them brilliant. So consider any two numbers 3 and 4. Now multiply them inside the logarithm. Outside, they will simply add up. You might not find this in many other functions, but logs are very special. They can take multiplication outside. Now this is the simple property of logs and antilogs. Consider the special cases. All the rest of the three properties that I am going to tell are simply the special cases of this property. 3 by 4 will give us minus. 3 raised to power 4, that is 3 multiplied by 3 times 3 times 3 will be 4 log 3. Similarly, if it is in the denominator, the power will be negative. These properties do not apply on antilogarithms. Now let us consider log table. We are finally arriving at the second part of the article, that is how to find logs using log tables. Remember that tables give us base to 10 unless it is specifically mentioned. General tables will have base to 10 only. We will find the answers of different values. So as an example, we have to find log of 0.8372. Now while calculating logs, I was quite confused. So I decided to create a sort of rule. Before considering the log table, just make the number in scientific notation, like write it as 8 point something. The decimal should be after only one number only, and rest you can take it to the 10 raised to power. So considering this, it can be written as 8.372 into 10 raised to power minus 1 and use the properties of logs. Now we will find the log of 8.372, put it in this equation, subtract it by 1 and get the answer. But first, let us find the log of 8.372 using log table. So in the log table, ignore the decimal and find the first two numbers. It's 83, find it here. Now the next number is 7. Now find 7 in the first kind of columns, that is in the red. It's here. Now match it with 83. We will get 927. Now find the last number, that is 2. Match it with 83 again. We will get 1. Add the two answers that we got. We will have 9228. Now the answer will be in non-scientific notation, which will be written as 0.9228. But this is the log of 8.372. Our question was 0.8372. Put it in the equation that we earlier made. Get the answer. Now, logs are very useful, but so far we have only dealt with values. We can even change the base of the number. Like we need to find log base to 2 of 10. To do that, what you need to do is simply find the log of the number with the base 2 that you know. Like we have to find log base to 2 of 10. We will find log 10 of 10 divided by the log of base 2 that we do not know. Solve it. Get the answer as 3.322. Now, as I said, log e, that is the exponential function, is also very important. Log base to e is known as natural log. You do not need to use the change of base again and again. Learn the formula. Log base to e is 2.303 log base to 10. As simple as that. Calculating antilogs. Now let us consider antilogs also. Considering the second example, antilog of 86.654. It can be written as 10 raised to power 86.654, but is it possible to calculate without any calculator or something? Not at all. To do that, what you need to do is first learn the formula for antilogs. Dealing with antilogarithmic tables, we use non-scientific notation. We have to get the number in non-scientific notation, but the answer will be in scientific notation. That is, it should be in 0 point something. So doing that, separate the powers. Write 10 raised to power 0.654 as antilog of that according to the definition. Find it using antilogarithmic table. Write the answer in the scientific notation this time. Put it in the equation and get the answer. So this was how to calculate antilogs. Did you know we can also find the antilogs of negative numbers? Our third golden example will tell you how to find antilog of minus 8.654. Remember, these examples will help you so much to find different sort of equations in logs and antilogs. So, to find the antilog of negative number, use the whole number next to the given number, plus and subtract that. It's a mathematical trick. So, plus 9 minus 9, use plus 9 and minus 8.654 will give us this. Now, antilogarithmic properties are a little different. You need not know them. So, simply write it as 10 raised to power minus 9, this number, and find the antilog of this number, that is 0.346. Do that. Get the answer as 2.218 into 10 raised to power minus 9. Negative numbers also dealt with. Now, finally, let us revise it. I know I've thrown a lot of information at you, so let us just revise what we have done. Tables give base to 10. Log e is also known as natural log. To do that, multiply log base to 10 with 2.303. Now, in a typical logarithmic book, tans, cotans, so on will also have the same procedure to find the values using tables, although their properties and rules may vary. Logarithms cannot have negative values. No one will ask you to find the logs of negative numbers, whereas they may ask you to find of antilog numbers. The rule for finding logs: use scientific, get non-scientific. The opposite for antilogs. Now, properties that we talked are only associated with logs. The general form of logs is log base to b of v equals a. And this is the point that I didn't tell you earlier. Log of 1 base to any number is 0. Finally, let us come to where we started. We started with solving this equation. Let us do that now. I will recommend you that you try to do it before seeing the answer from here. So, log both sides. Use the properties of logs. We will get x multiplied by log of 34 equal to log of 2 of 5.6, which will be equivalent to 2.313 by 1.531. Take log of 34 to the other side of the equation. Get the answer as 1.51.